Does this diet soda sink or float when I put it in the water?
It should.
Well, it has air in it, but the other soda has air in it too. Air is really light. It's pretty light. Actually, we're going to show how heavy air is in a few minutes. However, soda goes in, floats or sinks. What do you think?
Yes.
Let's do the experiment. And it actually floats. Regular soda, float or sink? Why? Because it's regular soda, right?
Yeah.
That's not a very scientific answer. If you put it on a test, you're going to fail. Regular soda, float or sink? Regular soda sinks in water. Regular soda is more dense than water. Diet soda is less dense. Do they give you more bubbles? Do they give you less soda?
Yes.
What do they sweeten this soda with to make it sweet?
Caramel.
And no, corn syrup.
Oh,
now that they're putting it in cars, we'll probably go back to sugar, but right now you need a lot of corn syrup to make it very sweet. This soda here has rat poison. I mean a little bit of NutraSweet to actually make it just as sweet as the soda here. There's only about 1 gram of material in there, so it's actually far less dense than this soda down here. Now, Sandy did a number on our beautiful Jersey and Coney Island shores and everything else, but has anybody ever been in the ocean? Has anybody ever been in a swimming pool? Where do you feel more of a buoyant force, in the ocean or a swimming pool?
Ocean.
In the ocean, why? What's in the ocean to make more buoyant? Salt, toilet paper, hypothermia. No, I'm just kidding. Yeah, lots of salt. So actually, if you take salt and you put it in this regular water bath, you'll know it actually brings that regular soda right to the surface, just like you in the ocean. This water is now denser than a regular soda. That simple experiment.
That's what you were saying to me.
What floats in our atmosphere? Balloons. No, air is our atmosphere. Air is our atmosphere. But there's two types of balloons that float in our atmosphere. You're actually going to do it. Do you think it's too windy or do you think we're okay? Okay. Okay. So, we have a helium balloon right here, which is the type of gas balloon that you usually get from the store. Let's say you have a birthday or something, they're going to give you a helium balloon. But there's a gas that's actually a lot cheaper and floats a lot better in these balloons right here. That's hydrogen. Let's take a look at the difference between a helium balloon and a hydrogen balloon. Art right here has some matches. You sure? Yeah. And you'll know, and most people are really scared of popping balloons. It just pops. All right? Over here we have the hydrogen balloons. I was just going to leave it on the rod and leave it up there. Yeah. Well, you're going to move the rod up. Move the rod up. You're good. You're good. It's not too windy yet. He's going to light all these matches at the end of the stick. He's going to light these balloons. You tell me the difference between the hydrogen and the helium. Now it's still going. Oh, it's still going. Hold still. Hold still.
Oh! Oh! What a difference.
There you go.
That was what?
See? En my opinion, it's a long time.
All right. Hydrogen combined with oxygen to form water. Please. Now, what were those balloons floating in? They were floating in air. We have a drum right here. It has a Rutgers R on it. So you know it's from Rutgers. It's from our chemistry department, actually. They're very nice to us. They gave us a bunch of drums. And what's inside this drum? What's inside this drum is air. What we have right here is that same pump that took all the air out of our ping pong cannon. We're going to take all the air out of this drum.
Really?
What happens to that drum when we take all the air out of it?
Here.
What happens? It's going to collapse, but it's a very heavy steel drum. So it happens all at once. It happens quickly. It happens really loudly. It's going to scare everybody. It's going to be a lot of fun. So let's start taking the air out.
Plastic.
I apologize to people in the front row.